Okay, so one thing I want to do is I really want to try to emphasize the difference between Ka and pKa. And the main difference, or the main reason that we don't always talk about Ka in terms of versus pKa is that there is a huge difference in size. So let's just take a look at these pKa's that we calculated and try to graph them. So what we're dealing with on this graph are two different molecules. So this molecule right here is our acetic acid, and this molecule down here is our HCl. Okay, so let me go ahead and orient you on the x and the y axis. The x-axis is our Ka, or our acidity. So basically what you're seeing is as we go from left to right on the graph, acidity is going up. So as we go down the pKa, or down the y-axis, pKa actually goes down, but the acidity also goes up. So as we're going down on the pKa, the acidity, you can see as you go down, acidity goes up. So as you go down, acidity goes up. And if you look here, this number is actually a little bit of a rounding error. This 0 is actually this 1.74 times 10 to the -5. But again, so Ka is right here, and pKa is right here. So 4.7, 4.7, 4.7. Okay, so one thing to not lose track of is that whenever you're comparing the pKa of the acetic acid, again, which is, this 4.7 number, so 4.7. So that's the pKa for the acetic acid versus -6 for the HCl. What we really have going on is that as we go down on the y-axis, as we go down in pKa, we're actually going very quickly across on the x-axis. So HCl is actually 1, 2, 3, not 1,000, not a million, not a billion, but 100 billion times more acidic than acetic acid. So HCl is 100 billion times more acidic than acetic acid, not 11 times. Okay, so always when we're dealing with pKa, always keep in mind that little changes in pKa make a big difference in terms of acidity.